Okay, so today we're going to go ahead and get started with the lesson, which is solving quadratics using the quadratic formula. Again, this is something you've already done, so it should be a fair portion of review, and then we're going to look at the discriminant and what that tells us. Okay. So as a review, we use the quadratic formula to solve a quadratic of the form ax squared plus bx plus c equals 0, where a, b, and c are whole numbers, and x squared and x, of course, are our variables. Our quadratic formula then comes directly from those terms, and it is x equals negative b plus or minus the square root of, I hope you're all seeing this right now, b squared minus 4ac, and then all over 2a. Again, a, b, and c come directly from our quadratic over there. So a is the coefficient in front of our x squared term, b is the coefficient in front of x, and c is the constant on the end. Because this is something you should already know how to do, we're just going to do 2 examples that use the quadratic formula, and then we'll move into the next portion of the lesson. So the first example I would like to do is I would like to solve this quadratic. So I have x squared minus 4x equals negative 1, and I would like to use the quadratic formula to solve this. The first thing I need to check before I can use the quadratic formula is I have to make sure that my quadratic is set equal to 0, or that all of my terms are on the left-hand side. So it's pretty clear to me that this negative 1 has to get moved over to the left before I can use the quadratic formula. So I do that, and I get x squared minus 4x plus 1 equals 0. I know the quadratic formula is going to be the best bet for me, because as I'm looking at this, I can't think of 2 numbers that multiply together to get 1 and add to get 4, or negative 4, sorry. So it's just not happening. So from here, I'm going to go ahead and use the quadratic formula because that's guaranteed to always work. So on this one, I'm going to go ahead and write out what my a, b, and c terms are. So a is the number that's in front of x squared. There's nothing there, so we assume it's a 1. B is the number in front of x, so here that's a negative 4. And c is the constant on the end, which here is 1. So in my quadratic formula, I have x equals the negative of our b term, which is negative 4, plus or minus the square root of that b term squared minus 4 times my a value of 1 times my c value of 1. And then all over 2 times my a value of 1. So I have negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 1, all over 2 times 1. So when I go ahead and I simplify that, I get positive 4, because a negative of a negative becomes positive, plus or minus the square root of negative 4 squared is 16, because negative 4 times a negative 4 gives a positive, and then minus 4 times 1 is just 4. 2 times 1 then is 2. I can reduce this farther by doing 16 minus 4, which gives me 4 plus or minus the square root of 12 over 2. Just like we did before, I need to reduce what's under the square root if possible. I do not want a fraction, though. I want to keep it as exact values. So I take square root of 12, and I ask myself, okay, what can I multiply together to get 12 that includes a perfect square? Well, clearly, 4 times 3 equals 12, and 4 is a perfect square. So I have the square root of 4 times the square root of 3. Square root of 4 is 2. And then the square root of 3 is non-reducible. So the square root of 12 simplifies into 2 times the square root of 3. So I have 4 plus or minus 2 times the square root of 3 all over 2. From here, I should reduce if I can. The only way I can reduce is if I have a number or a common number that comes out of all 3 of the whole numbers present that are not under the radical. So here that's 4, 2, and 2. Good news for us, 2 comes out of all of those. 4 divided by 2 is 2, plus or minus. 2 divided by 2 is 1, which just leaves the radical 3 right there. And 2 divided by 2 is 1, which means my denominator is now 1. So this gives me my 2x values. 2 plus the square root of 3 and 2 minus the square root of 3. I'm okay if you want to leave it as plus minus all as 1. That's perfectly fine, as long as it's inside the curly brackets. Anybody super confused by quadratic formula? Hopefully you all actually remember how to do it. So this is just a nice little review for you. Okay, then let's go ahead and do another one. So let's say that I have a function that is 3x squared plus 5x plus 4. I sing it in my head, cadence, every time I do this. And I actually didn't even know it existed until 2 years ago when my kids sang it for me. That was not a thing when I was younger. But I'm glad you guys have it now. So I have the quadratic 3x squared plus 5x plus 4. Pretty clear here that using the quadratic formula is going to be the easiest route to solving this. So I need to identify what my a, b, and c are. So a is 3, b is 5, and c is 4. It is perfectly fine to not have a c value or not have a b value, okay? So if I didn't have that term, I would just put a 0 in there. So just make sure you are aware that that is okay. So a is 3, b is 5, and c is 4, which now allows me to plug those values into my quadratic formula. So I have x equals negative 5 plus or minus the square root of 5 squared minus 4 times my a value of 3 times my c value of 4. That's all under the square root. All over 2 times my a value of 3. From here, I just go ahead and write reduce. So x equals negative 5 plus or minus the square root of 5 squared is 25. 4 times 3 is 12. Times 4 is 48. And then all over 6, because that's what 2 times 3 is. Bring that up here and continue simplifying. So I have x equals negative 5 plus or minus the square root of 25 minus 48 is negative 23 over 6. Uh-oh. I have a negative value underneath my square root sign. I can't take the square root of a negative number. So do I have to stop here, or can I keep going using some other information? Yes, we can use I to remove the negative from under the square root, which will allow me to continue simplifying, but I will know that my answers will have an I in them. So they are technically imaginary answers, but they're still zeros that could theoretically exist. So I'm going to go ahead and take the I out. When I take it out, it just sits out front, and then what's under the square root becomes positive, which allows me to continue simplifying. So now I have negative 5 plus or minus I times the square root of 23 all over 6. I need to ask myself, okay, what perfect square can I divide out of 23? None of them. 23 is a prime number, so there's nothing I can do with that, which means there's also nothing I can simplify, because there is nothing that comes out of negative 5, 1, and 6, which means that this entire thing right here is my set of zeros or solutions. So x equals, in curly brackets, you can leave it together if you want to. Negative 5 plus or minus I times the square root of 23 all over 6. And I'm finished because there's nothing else that I can do with that. Anybody super confused by the quadratic formula? Fantastic. So the quadratic formula tells us what our solutions are. So they actually give us the numbers that are the zeros or the roots or the solutions to my quadratic. But what if I didn't want that information? What if I just wanted to know the types of solutions that I would get for a quadratic and not actually what they are? Well, I could go through this super long process and I could get down to my answer and say, oh, I got 2 complex numbers. So this quadratic is going to give me 2 complex solutions. That's a lot of work for that small little piece of information. So there's actually something else that we can use to identify this, and that is called the discriminant. Hopefully this is something you've heard of before. The discriminant is actually a piece of your quadratic formula. In fact, it is the piece that is under your square root. So it is b squared minus 4ac. That whole thing gives us one number, and that one number is the discriminant for our quadratic. The way we determine what types of solutions we're going to have is by what answer this discriminant comes out to be. Okay? So there are 4 different types of solutions technically that we can have. The first one, if b squared minus 4ac comes out to be a positive number, so greater than 0, that is a perfect square. So our perfect squares are 4, 9, 16, 25, 36, and so on. So if our quadratic comes out to be a positive number that's also a perfect square, it tells me that the solutions to my quadratic will be 2 rational solutions. If that discriminant comes out to be positive, but not a perfect square, so any number other than 4, 16, 25, 36, and so on, then my solutions will be 2 irrational solutions. Rational numbers are numbers that can be written as a fraction. Okay, this also means that they are decimals that end or that repeat. So 2/3 is a rational number because when it's written as a decimal, it's 0.66666 repeating. An irrational number is any number that does not terminate, nor does it repeat. Okay, so pi. Pi is an irrational number. So is the square root of 2. Okay, so any number that ends, so whole numbers, decimals like 1/4 or 1/2, those are all rational. Okay, make sure you know the difference. So we've covered what happens if our discriminant is greater than 0, right? If it's a perfect square, we have 2 rational solutions. If it's not a perfect square, apparently I can't spell, then it will have 2 irrational solutions. But what if it's equal to 0? So if my discriminant equals 0, we call this a double root because it's the same number twice. And we would say that it has a double root or 1 rational solution. The last type of solution then that we can have is the one that occurs when our discriminant is less than 0. Okay, so a negative number. This means that I would have 2 complex solutions, which means they would have an I in them, like that last example that we just did. Okay, so the 4 different types of solutions we can have. If it's greater than 0 but a perfect square, we have 2 rational solutions. If it's greater than 0 but not a perfect square, we have 2 irrational solutions. If it equals 0, we have what's called a double root, or 1 rational solution. It would just be repeated twice technically. And if it is less than 0, then I have 2 complex solutions. So we're going to go ahead and use this information then to identify the discriminant and the types of roots for 3 example quadratics. Okay, we're not actually solving them. We are just identifying the types of solutions using the discriminant. So the first one we're going to use is x squared plus 4x plus 4 equals 0. I'm just identifying the types of solutions, so I only care about the discriminant, which is b squared minus 4ac, using the same a, b, and c that we used before. So my a value here would be 1, my b is 4, and my c is 4. So I go ahead and plug those numbers in. I get 4 squared minus 4 times my a value of 1 times my c value of 4. I simplify it. 4 squared is 16 minus 4 times 1 is 4 times 4 is 16. 16 minus 16 is 0. So my discriminant is 0. Okay, that 0 right there is my discriminant, which means by all the information we wrote down up there, we would have 1 rational solution. Again, this is also called a double root. Okay, next example is the quadratic 8x squared equals negative 14x minus 3. Just like I would have to do if I were doing the quadratic formula, I need everything on the left so that I can correctly pull out my a, b, and my c. So I'm going to add the negative 14x and the 3 over, which gives me 8x squared plus 14x plus 3 equals 0. Again, from here, I'm pulling my b squared minus 4ac. My b is 14. So 14 squared minus 4 times my a value of 8 times my c value of 3. 14 squared is 196 minus 4 times 8 is 32 minus, 32 times 3, which is 96. 196 minus 96 is 100. So 100 is our discriminant here. That 100 is positive, and it's a perfect square, which leaves me, by the information we wrote down up there, with 2 rational solutions. Or 2 rational roots. You could write it that way too. Okay, let's go ahead and do one more example, and then you are free to work on your homework. So the third example we're going to go ahead and do is the quadratic 2x squared plus 4x plus 1 equals 0. Everything's on the left-hand side, and it's simplified, so I can just go ahead and do the discriminant portion here. I get b squared minus 4ac. My b is 4, so 4 squared minus 4 times my a value of 2 times my c value of 1. 4 squared is 16 minus 4 times 2 is 8 times 1 is 8. 16 minus 8 is 8. 8 is a positive number, but is not a perfect square, which means I'm going to have 2 irrational solutions or roots. And I'm finished. So your homework is a combination of using, the quadratic formula to find the roots, and then using the discriminant to identify the types of roots and how many you will have. Okay? If there are no other questions, then your homework is on Canvas. It is due tomorrow. Feel free to go ahead and get started on it. As always, I will remain on this Google Meet until the end of the class period. And from there, if you have any questions, you can just go ahead and email me. Okay? Any major questions, concerns, or issues right now? Fantastic. Okay, we'll go ahead and get started on your homework. I will post this video after it's done downloading. So have a great day.